All right, in this platform, we shall be focusing on the similarity concept. This one, it's a nice question that we have to learn a lot from our similarity concept. We have got in the diagram, SR is parallel to PQ. Actually, this is a parallelogram. We are having a trapezium, not a parallelogram, but we are given a trapezium in this case, whereby these two sides are parallel, but these ones, they are not parallel, the other two. So from this trapezium that we have, we are given the side SR and PQ being parallel, and also that these two, they intersect SQ and PR from P to R intersect at T. So meaning to say these two lines, they intersect at a point referred to as T. Given that PT is 10 centimeters, then also we are given from R to T 2.5 centimeters, PQ 16 centimeters. Calculate SR. All right, so this is a type of a question that you see that even you're solving triangles cannot even solve this type of a question to find this length. The bearing part, we can't be even be thinking of all those topics. So how do we attempt such type of a question whereby you are given this type of a condition? All right, we are going to think about the similar figures since these two are parallel. So we are going to be thinking of similar figures, knowing that similar figures, I explained that these are similar figures or similar triangles. When you are talking about triangles, they are equiangular. So the concept there is that they are equiangular. What does the part equiangular mean? We are talking in terms of the angles. If we are referring to two triangles which are similar, they are not because of being the same in terms of the size, no, but they must be the same in terms of the angles. If we are saying these angles are equal, therefore these two triangles are going to be similar due to being equal to say this angle and this angle, they're equal. This angle and this angle, they're equal. This angle here and this angle here will be equal. That's how you take the similar figures. They are taken from similar figures. And I explained that the ratio of sides of similar figures is the same. So knowing this concept, we can think of finding the similar figures where the SR is contained. So if we check, we've got this triangle here with the concept of parallel lines. We are going to see that if we check these two lines which are parallel, we are going to take the angle at S and the angle at Q from our alternate angles, the ones that create a Z. As we can see here, we are creating a Z at Q and at S. So meaning to say these two angles will be equal. It is the same thing if we create a Z here at angle R and at angle P like this. As you can see, we are creating angle here and angle here. So the angle that is at R, this angle here at R is going to be the same as the angle at P. All right, going to the angle that is T, we will see that the angle T, this angle here is the same as the angle T on the other side, from which concept we are referring to the vertically opposite angles. Remember, from two straight lines, the angles that are opposite equal. Vertically opposite angles are equal. So this is the concept that you are using in this case. All right. So like I said, similar figures are equiangular. You are going, since you are not given a triangle that is similar, you are the one who is to name the two triangles which are similar. So let us name the first triangle. Let's say I decided to use my first triangle because this one, it's your choice. You are the one who chooses to take the first triangle. I can choose SRT as long the side SR is involved. As you can see, we are having this in this triangle. So I can choose STR, I can choose SRT. The first triangle is of your choice. All right, so in this case, I'm going to take this as triangle SRT. All right, so triangle SRT is similar to, so this is the sign for similar to. All right, so you're saying, according to equal angles, we check angle S is equal to which angle? We said angle S is equal to Q. So that's how you name the other triangle. This second triangle is supposed to be taken from the first triangle. The first triangle gives us the second triangle. But the first triangle, this one, it's of your choice. This one, it's of your choice. But the second one, it's no longer of your choice. You take it according to equal angles, S and Q. That is how you're going to relate your angles. All right, so let us move on to the other angle. We have got R in this case. So which angle is equal to R? R, we said, is equal to P. So this is going to be P. All right, we move on to the other angle, which is T. We said T is equal to T. This T here and this T are the same from our vertically opposite angles. So this will remain as a T in this case. All right, so this one is going to remain as a T. So meaning to say triangle SRT is going to be similar to triangle QPT. If we take this in terms of the sides, if I said for the first triangle, let's say I chose it to be RTS, this is your choice, RTS, meaning to say it is going to be similar to, you take according to equal angles R and P. So this one is going to be triangle P, T versus T. T and T are the same. Then S, and Q. So these are the similar figures. The first triangle gives us the second triangle. All right. So in this case, I'm going to work with the first choice that I have made for triangle SRT. So what then next follows? Ratio of sides. Think of the ratio of sides. Once you have got similar figures, think of the ratio of sides, because we are saying the ratio of sides is equal throughout. So the ratio of sides is equal. So we're going to have the ratio of sides that is SR, this side SR here. So it's going to be SR over the corresponding side on the other triangle, which is QP. The way it is S to R, Q to P. So this one is going to be QP is equal to, we move on to the other one. If we move from R to T like this, RT. So we are saying RT over the corresponding side here, R and T, Q, P and what? Q and P and T in this case, R and T, P and T. That is how you're supposed to take this. So this is over PT is equal to, again, if you check, we are having another one from S to T and from Q to T. So S to the last point, Q to the last point. So this is going to be ST over Q over QT in this case. All right. This is our ratio of sides that we are having. So from this ratio of sides, I want you to check where are we having SR, because our question here is to calculate SR. So we check the ratio that contains SR. If we check the first one, it consists of SR. So we're going to take this first one. Then for these two, we are going to check which ratio has got corresponding values on our diagram, which one has got corresponding values on the diagram. So let us check this one, RT. Are we having RT? R to T we have, PT from P to T we have. So this one, we can relate it. ST, from S to T, we don't have anything. From Q to T, we don't have anything. So this ratio is useless for us to work with. We are going to leave it like that, all right? So we are going to work with these two ratios where there is SR and the ratio that has got complete values from your diagram. That those are the ratios that you work with. So we are saying SR over QP is going to be equal to RT over PT. Then you substitute your values. SR is the one that you're supposed to calculate. So it is going to remain as SR over QP. From Q to P, that is 16 centimeters, is equal to RT. From R to T, that is 2,5. So you're going to have 2,5 over PT. From P to T, that is a 10. So that is what you're going to obtain in this case. So from this, we are saying these two are equal. This is our ratio of sides. If we are to simplify 2,5 over 10, that is our ratio of sides, or we can just leave it like that. But this is what is your ratio of sides, the same as this one. It is the same as this one. The ratio of sides is the same throughout. So using this, we can find SR by cross multiplying, because this is now an equation. So we can cross multiply 10 times SR, that's 10 SR is equal to 16 times 2,5, which is 40. So to find SR, you can simply divide by 10 both sides, since here we are multiplying by 10. So this will cancel, and our SR is going to be remain as 4. The units the units are very, very important. Our units are in centimeters. So that means from S to R, we have got 4 centimeters. From S here to R, we have got 4 centimeters. So what I was trying to say is that if we are to substitute, we must have the same ratio. It means the ratio of sides in this case, like I was saying, the ratio of sides is the same. So if we are to check this from our ratio of sides concept, let us check. The first one here, I said this one, it's a ratio of side, RT over PT. That is the ratio of side. So if we are to use our calculator, all right, this is paper 2. Let me bring the calculator so that we can check what I'm trying to explain here. All right, so let's say we've got our calculator here. We want to use this fraction 2,5 over 10. Let us see what we have. 2,5 over 10, it's 1/4. So meaning to say our ratio of sides is 1/4. If we take SR, this value that we got here of SR, and substitute it here and say 4/16, we must have the same answer or the same ratio. If we say 4/16 like this, we are having 1/4. So that's why I was saying the ratio of sides is the same throughout. It is going to be the same, meaning to say also, if you are asked to find the ratio of ST over R over QT, the ratio here is going to be 1/4 in simplest form, because the ratio of sides must be the same throughout. All right, so that was the concept that you're going to use to calculate SR in this case from the first question. Let us check the other part of the question. Item 2, you are now given the ratio of area. Take note, we are now talking of area of triangle RTS to the area of triangle PTQ. All right, RTS, this is our triangle here. The ratio of area of triangle RTS, which is this triangle here, to the ratio of area of this bigger triangle here that we have. If we check these two triangles that I am indicating, these are the triangles that we were working with here. If you check, these are the triangles that we worked with here. SRT, which is the same the way that it is given here, RTS. They just took the order of RTS. PTQ, if you check, this is our triangle that we had as QPT. So meaning to say here we are simply playing with the same ratio of sides. All right, so I just want to remove this part here. All right, we are simply working with these two triangles that are similar. From this part, we said these two triangles, they are similar. All right, so what is it that you consider from similar figures? Because the question is asking us to calculate the ratio. Take note, the ratio of areas. All right, so it follows that from similar figures. All right, let me explain it this way. From similar figures, we are talking about similar figures here. From similar figures, or from similar shapes or similar triangles, the ratio of area is equal to the square of ratio of sides. So we have got the ratio of sides in this case squared. So it is the ratio of sides squared. Area, remember, area is measured in square units. So meaning to say, to answer our item 2 in this case, which is asking us to calculate the ratio of areas, which is these two triangles that we calculated before, their ratio of sides. And we said the ratio of sides of these two triangles is 1/4, which you can take from any corresponding ratio that you have. 2,5 over 10, it gives you ratio of sides. So you have the ratio of sides, which is 1/4. So therefore, the ratio of area is going to be 1/4 squared, like this. That's 1 squared, which is a 1. 4 squared, which is a 16. So that means the ratio of areas in this case is going to be 1:16, or 1/16, of which you can write it as 1:16. So this is the ratio of areas. That is in terms of area. What it means here, in terms of area, since we said our ratio is 1:16. So what does it mean? It means RTS, this triangle RTS here, in terms of area, it consists of one part, and this one, it consists of 16 parts. This one, it consists of one part. This one, it consists of 16 parts of the area, not to say this is our area, but of the area, 16 parts of the area. So this is how you take the ratio of what? The ratio of areas if you are given what? If you are given similar figures. That is why I said from similar figures. Ratio of area is ratio of sides squared. All right. If you check this one, it's different, but it's asking us about the ratio of areas. Take note. Now they want the ratio of areas of triangle PTQ to the area of triangle QTR. All right, let me write them on top so that we properly use this diagram. Triangle PTQ. So we need the ratio of triangle of area of triangle PTQ. Let me write them here. Triangle PTQ to the ratio of triangle, the other area that we need of triangle QTR. So we want to the ratio of QTR. So this is area, this is area, this is ratio of area. All right, let's check our triangles first. PTQ, this is where we have triangle PTQ here. This is our triangle PTQ, this whole triangle, this one. All right. QTR, this is the triangle QTR, this one. These two triangles that we are given, they are not similar here. We don't have any angles that we can relate to say this angle is equal in these two triangles which are combined here. We do not have that condition. So what are we going to do? Because these two triangles, they are not similar. They are not similar. All right. What is left is this condition. If the two triangles are not similar, because we said similar figures are equiangular, you check for this last consideration to check if the two triangles are having the same height, connected with this on the same base and having the same height. They are sharing the same height. If they do so, you are going to use the concept that the ratio of sides becomes the ratio of areas. On this condition, this triangle 1 to triangle 2, area or ratio of area of triangle 1 to the area of triangle 2 in this case is going to be taken as A as to B. You do not square anything. You don't square any side to say these figures, they are not similar. They just share the same height. Once it's like that, you are going to take the ratio of sides. That ratio of sides is your ratio of areas. That is how you take this one. All right. So is this condition appearing? If we check here, these two triangles, PTQ, and QTR, they share the same height. This one from from T to Q here, they are sharing the same height, QT. Found these two triangles on this base sharing the same height. So meaning to say we are going to use the ratio of sides. That is from P to T from this triangle. This is same as our A in this case. So our ratio is going to be 10 as 2. We move on from T to R on this other triangle. We are given a side which is 2,5. The ratio of these sides is the ratio of areas if these two triangles are not similar. So this is our answer, but we can simplify further. This is a comma. So to remove a comma, we've got 1 decimal place multiplied by 10. Whatever you do here, you do it on the other side. So here also you're going to multiply by 10. 10 times 10, that will be 100 as 2. 2,5 times 10, we just move 1 comma, so this is going to be 25. But this ratio is not in simplest form. We can reduce by 25, both sides reduce by 25 by 25. So 25 into 25, 25 into 100. That is the idea there. All right. So if we are to reduce 25 into 100, it's going to give us 4 as 2. 25 into 25, which is a 1. So this is the ratio that you're going to have. The ratio of sides that you were given is your ratio of areas, which is different if the triangles are similar. Take note here. If triangles are similar, that's why I indicated from similar figures, the ratio of areas now is ratio of sides square. You have to square the ratio of sides, the one that you obtained from your similar figures. When you said these two triangles are similar, you obtain a certain ratio from there, from any corresponding side, either SR over 16 or 2,5 over 10. any part can give you ratio of sides, but you are supposed to square that ratio of sides when you are dealing with similar figures. So these are the typical questions on similarity. We shall meet again having other questions to revise on, particularly for the exams which are ahead of time. This is the right time to work with more questions, more question papers. Prepare yourselves for the exams which are ahead of time. But for now, that's it till we meet again.